My name is Luke Kennedy and I've just completed my studies in a joint degree in electrical engineering and information technology at JCU. I went to high school at Mareeba High School. I studied a lot of maths related subjects. In grade 9 I did a subject called Project Science Maths, which was about teaching kids how they can integrate the various things they've learnt in maths and other areas into robotics and programming. So we started being taught the Turtle programming language and moving a little icon around the screen, drawing various things, and moved all the way up to programming Lego Masterminds contraptions to do things like drive around or control an elevator. The programming subject definitely enabled me to apply maths, to see how I could apply maths in different ways. I recently worked on a project where we developed a drone designed to deliver a package by flying to a particular location using GPS and then using a camera to identify the corners of a net for it to drop the package off in. It would allow packages to be delivered in areas that would otherwise be difficult or time-consuming to reach by traditional means. So in built-up urban areas where there might be a lot of congestion, or other places, say at the top of an office building. The drone could also be used to deliver packages in areas that are very difficult to reach. You could have a drone fly a long distance to deliver a package to a remote building. There were 4 electrical engineering students in the team and 1 electrical engineer professional overseeing as a supervisor. My role in the project was to write code for the drone to control it and move it around as the package was delivered. The rotation of the servos is just controlling how far the little arm that holds the package in rotates around so that it's either holding in the package or allowing it to drop. Some of the maths that was involved in controlling the servos were percentages and time calculations, and those corresponded to various angles that had to be put at. A lot of the calculations regarding the movement in various coordinates were based on Pythagoras' theorem or some more complicated trigonometry. When the drone is approaching the net, we have the drone sitting there, that sort of propellers, and the net will be somewhere down here with sensors on each corner. The camera can only see in a certain cone, but we want to be as low down as possible so that the package is safe when we drop it. We don't want to be dropping it from that height, but if we come too close, the net will be there and the sensors will be out of view. So you need to be able to calculate how high you want to be able to go to be as low as possible for the safety of the package, but high enough up that the camera can see it. So you want it to be there. But to calculate where that is, you need to be able to take the distance to the sensors and the angle to the sensor and calculate that height using Pythagoras' theorem and using trigonometry. The best part of working on this project was definitely being able to just push a button and see the code you just wrote have a real effect on the drone. When I did maths in year 11 and 12, it definitely helped that I'd been interested and good at maths in the lower high school grades. To be able to go on and learn the more interesting, more advanced stuff, you have to have a good understanding of the earlier parts. There was an advantage that I had in having done the maths at school, in that I was able to understand and develop faster the skills that I was learning in university, because the maths that you do at the beginning of university is very similar to that you would do in Maths B or C. What I'd really like to be doing in the future is working in control systems. Control systems is a field typically of engineering where people program machines to control other machines. Working in control systems can produce things like the drones that I worked on, but it can also produce things like the GPS-controlled harvesters and tractors that we already see in farms, the self-driving cars that Google's working on, all sorts of things that will come up in the future that I can't even predict. It's very important that people in high school study maths, because if you don't have those skills, there are going to be less and less jobs for people without them. If you just look at the checkouts at supermarkets now, you've got 1 person manning 6 self-serve checkouts. You've got 1 person doing jobs that 6 people have done before. Things like robotics and automation are going to continually take more and more of this labour and do it more efficiently and more cheaply. The sort of jobs that will be available will be the jobs of people making and programming these machines.